I think the first time I ever asked students to make a problem like this, to go into the lab and do something like that, they freak out a little bit. Meaning, I want you to combine copper and copper chloride and hydrochloric acid. And I want it to be 0.57 molar hydrochloric and this many molar copper chloride. And I'm like, all right, go in the lab and make something like this. And the students look at me and go, how can a solution be some molar of one compound and some molar of another compound? Well, don't forget that molarity is simply telling you how many moles of whatever it is are inside of a volume. And so whenever we're thinking about things like that, it's not like you can only have one thing in a solution. That would be crazy. We wouldn't have detergents, hair products, I don't know, we wouldn't have a lot of life, okay? So you can have different things that will describe the same solution. It's like saying I have my fish tank, and my fish tank is this many parts per million phosphate, this many parts per million ammonia, whatever. You can have lots of chemistry terms describing the same solution. So this problem has you do the reverse. It tells you how you're making your final solution. I want to know what is the final molarity of a chlorine ions that are going to be present when you combine these two mixtures together. So how do we do that? All we got to do first is figure out how many moles of chlorine we have. How many moles of chlorine does hydrochloric contribute, and how many moles does copper chloride contribute? After we do that, you just divide by the total volume and you've got a molarity. So let's try it. I'm going to convert both of these milliliters to liters. Liters times, remember molarity is just moles per liter, so 0.570 moles of hydrochloric per liter. So my liters are going to cancel. And then how many moles of chlorine ions are going to be present in 1 mole of hydrochloric acid? 1. So we've got 1 mole of chlorine ions. And that's going to give us a total of 0.14535 moles of chlorine ions. Same process now for the second part of our problem. 0.175 liters times 1.375 moles of copper 2 chloride, per liter. Now we ask the same question. In 1 mole of copper 2 chloride, how many moles of copper are there? And there are 2. So that gives us 0.48125 moles of chlorine ions. But what do we do with all this? So like I said before, this is telling us basically how many molecules of chlorine ions we have floating around in our solution per each of our solution. Where do they come from? So in this case, we've got 0.14535 plus 0.48125, both of these having units of moles of chlorine, all over, and this is concentration of chlorine, all over my total volume. So remember, my total volumes are here. 0.255 liters plus 0.175 liters. Do that math and you end up with 1.457 molar chlorine ions. Now, a lot of times it may be confusing to compare this to your initial work. What I mean by that is oftentimes I ask you to do a common sense test, which means if you combine two solutions, shouldn't the number of them be between the two? Yes and no. If it were one of these two compounds, maybe, but we're looking at chlorine ions, and because it's 2 to 1, we actually end up with a value that's greater than the individual molarity that we used to create it. So there's our final answer, but the idea is still simple, that you got to think through molar conversions and then think through what's the chemistry, what's the concept that's being tested here. Where did the sample come from? How is it being analyzed in the end? And if you keep those things in mind, you'll be able to do almost any problem in quant, because this is basically quant in a nutshell. It's thinking through and then figuring out how can you use your math to generate an answer in the end.